In the name of Allah, the compassionate and the merciful. Hello guys. In this video we're talking about steel rebar diameter optimization based on moment curvature. Based on previous videos about moment curvature analysis in Python, which we defined the code and process of this analysis. At the end we get this kind of moment curvature lines. As a blue line, it shows the analyzed unconfined moment curvature analysis, and also the red one is the bilinear curve fitted of moment curvature analysis. If we see that this red line, the first slope of this red line is called elastic flexural rigidity, and the second line with the low slope called plastic flexural rigidity. And you see that we defined, based on previous videos about moment curvature analysis, we defined two layers of steel rebar, and with different steel strain and stress relations for steel rebar and unconfined concrete, compression and tension zone. In this analysis, after running the moment curvature analysis, we wanna find the best steel rebar diameter based on defined ductility ratio. So at the first we defined ductility ratio, and we want to find the optimum steel rebar diameters for layers, for example, layers of AS1 and AS2. So let's back to the Python code. You see that based on previous videos, all the code has the same. We define axial load analysis for finding the axial strain, for applied load definition, moment curvature analysis, and you see that a bilinear curve fitted for finding the two line with the moment curvature curve fitted. And in here we calculate the elastic and plastic flexural rigidity, and also ductility ratio and overstrain factor. And then in here we wanna analyze the optimum rebar diameter with Newton-Raphson method. You see that I use this method in a while cycle, while residual is greater than tolerance, so the analysis is going to be continue. And I defined this method for calculating of F equals to ductility minus maximum ductility ratio. So for better convergence of our analysis, I defined a range for minimum and maximum value for our analysis, not just not a fixed number, because it is very hard and for complex nonlinear analysis such as moment curvature analysis to finding the exact ductility ratio. So I defined the minimum and maximum ductility ratio for better convergence of our analysis. You see that in here I defined the maximum one for better convergence, and I defined the minimum epsilon and maximum epsilon, and then in here I defined the derivative function for calculation in Newton-Raphson method. In here, we decrease and update the rebar diameters based on Newton-Raphson method. And if the iteration reached the ultimate, so the analysis is going to be stopped. And if the ductility ratio is greater than minimum and less than maximum, so analysis is going to be stopped. And at the end, the time is going to be shown. If we run this code, you see that the number of iterations and all the analysis is the same based on previous videos. But if we run this code at the end, you see that the analysis is going to be converged with 7 iterations based on defined value, and the optimum rebar diameter is equal to 35.77 millimeters, for example, in this analysis. And also trying to plot it with this rebar diameters and the last moment curvature analysis, you see that it has this shape. And elastic flexural rigidity and plastic flexural rigidity is going to be calculated too. So you see that in this analysis, it is very hard to find the exact ductility ratio based on this complex nonlinear moment curvature analysis. So we defined range between minimum and maximum values. And if we defined just, for example, one ductility ratio with the constant number, so it is very hard and it takes many time to find the exact value of this analysis. So, for example, if you want to calculate the overstrain factors, even elastic or plastic flexural rigidity, you can change these parameters. For example, in here you can define overstrain factor and define it and change the values to finding the optimum steel rebar diameter based on defined overstrain factors. Okay, guys? So you see that in this analysis we use the Newton-Raphson method in a very complex moment curvature analysis for finding the optimum rebar diameters. So thanks, guys. Please have a comment and tell me know about this kind of modeling. Bye.